Hi, I am Venkatesh Pane. This video is about a project for IBM TechXchange Hackathon on the theme of sustainable cities. The core concept is creating an AI agentic environment that helps users easily access city information and generate reports on work progress. Project A.U.R.A, Amaravati Urban Resilience Agent, is conceptualized as more than just a management system. It is the digital life force of Amaravati. The setting for this innovation is the Amaravati Capital City project, an ambitious plan to construct a new capital for the Indian state of Andhra Pradesh, which is situated in the bank of Krishna River. IBM watsonx Orchestrate is an AI-powered platform that enables users to automate business tasks and workflow through the use of intelligent agents. Our city report assistant is one of those agents. It is developed to generate reports on a defined template by accessing city data in an external database. The reason behind this error is that some of the connections are offline, maybe are not connected well. In a design workflow of agentic systems, several things could have gone wrong. Maybe the AI agent failed to establish connection with the API server, the database server is offline, or the database have not yet been loaded onto the server. Let's start building back again from the scratch. A city is like a big web of connected things. Every building, sensor, and pipe holds important information. To run a city well, you need to see how everything connects at once. But the usual way of handling this much complex data are difficult and very slow. To solve this problem, the project uses a smart way to organize the data, an ontology, which decides what and how data was connected with each other. The first step was making a basic plan called Ontology schema. This plan lists all the main parts that make a city work, like buildings, roads, and pipes, and shows exactly how they all connect to each other in an organized way. This plan was built using RDF library, a open source Python-based tool for developers. The result is a special ontology named ADTO, which stands for Amaravati Digital Twin Ontology. In simple terms, ADTO is a main rule book for the city's data. It clearly explains every single part of city and how it is connected to everything else, creating a smart map of all Amaravati essential systems. The next job was to transform the ontology schema from a blueprint into a live graph database by adding a real-world data. This data was taken from the official Amaravati master plan, which is published on the government website. Using QGIS, an open source GIS software, map data was extracted into a simple and effective GeoJSON format. For the scope of this project, the data was limited to 3 key areas: the city's road network, the water supply system, the unofficial zoning. To convert GeoJSON data into a RDF graph, a Python program was developed. The program job was to ingest this data into a ADTO schema, using the vocabulary that had already been defined. Finally, the result is a database that is not just a collection of data points. It is semantically and logically a structured knowledge graph, strong enough to interact with AI agents. It is saved in a TTL format, a simple and effective file format used in the knowledge graph question answering systems. Tools like a Protege, a popular open source ontology editor, allow for user-friendly development and editing of these ontology files. Inside the graph, data points are stored as individuals that belong to a class and hold all their attribute data. For example, a trunk road named E8 might have 2 road segments. The graph can show that one segment is in completed status. And you can also verify its exact location in the city network by using geographical data that is stored in an ontology schema. Furthermore, this piece can be connected to a related information like its specifications, maintenance history, or traffic flow data. This is what makes the ADTO knowledge graph so much stronger and more informative than a traditional database. Once the database is set, the next step is to take this knowledge graph from a static file and bring it to life on a server. For this, the project uses a Apache and a Fuseki. Fuseki is an open source server that hosts the knowledge graph, making it is accessible over a network for AI agents and its applications. A key feature in this is a Sparkle endpoint. It is a direct web address where AI agents use the Sparkle query language to ask complex questions and get answers directly from the live knowledge graph. Once it is done, the next step was to connect this database server to an API server, which act as an intelligent middle layer. While the Sparkle endpoint allows direct access, a more refined approach is needed for practical applications. This server has two main jobs. First, it is simplify query by providing clean API for AI agents, hiding the complex Sparkle logic. Second, it performs advanced geoanalytics using Python to run complex location-based calculation on data from the graph. The final step is to connect this powerful backend to an intelligent agent. This is achieved by using IBM watsonx Orchestrate and its application development kit. The ADK is a toolkit that allows developers to create agents and tools in a standard format called an Open API specification. These specifications act as an instruction manual, telling the AI assistant exactly what each API does and how to use it. Once this manual was imported, the AI agent gained a new skill set. It can now autonomously query the Amaravati knowledge graph to answer complex questions and generate reports, and truly bringing the A.U.R.A agent to a life. For the user interface, instead of a typical chat platform, the A.U.R.A agent is connected directly to a WhatsApp. This allows citizens and city planners to interact with a powerful backend simply by sending messages. The A.U.R.A ecosystem is not run by a single agent. It is a multi-agent system where different agents collaborate to perform a sophisticated task with a precision, each using its own set of specialized tools. This allows the system to answer a specific user question, such as the current status of road segment, the location of nearby school, or total area of green shore. While this demo is focused on road network, water supply, and journeying, the system is designed to scale as more data and new use cases are introduced. A key challenge is that an agent cannot memorize the entire knowledge graph, especially since the data changes dynamically. Generating an accurate Sparkle query from the user question is therefore a challenge task. To overcome this, a dedicated agent called Knowledge Graph Service Agent was created. This agent acts as an expert on the database structure. Using tool check schema, it regularly updates its core memory of the graph layout. It then serves as a helper to other agents, providing them with a necessary schema knowledge. Manual validation of over 100 queries in the Fuseki server confirms that the system accuracy is over 80%. The final words. Project A.U.R.A demonstrated a significant step forward in urban data management. By combining the structural power of knowledge graph with the autonomous capabilities of multi-agent system, a true digital life force for a city like Amaravati is not just a concept but an achievable reality.